Okay, then we can go ahead and get started. Hello, everybody. I am James Snell. I am on the Node Technical Steering Committee. I'm also with Cloudflare on the Workers platform team. We actually work on the runtime itself, which means I have the distinct pleasure of working on two completely different implementations of exactly the same stuff that work almost very similar in entirely different ways, which is a lot of fun. I ended up implementing the web stream spec 3 times in 9 months, which was kind of a fun exercise. I don't have any slides today. I'm going to just saying I was thinking about putting some together, but everything I want to talk about we could just talk about. I don't have to put it up on the slides to get the info across. If you want to get in touch with me afterwards or ask questions, I'm easy to find. I'm J.A. Snell on Twitter. You can find me on GitHub anywhere. You can feel free to reach out and contact me anytime. Pretty easy to reach. What we are here to talk about is kind of a standard lib for JavaScript and kind of what that means and what we're doing to develop it. So if we back it up just a little bit, Node, you realize, man, geez, it's like 12 years old now. It came out quite a while ago. When Node emerged into the ecosystem, it was just Node and browsers, right? And this whole concept of JavaScript, in places outside of the browsers was just really starting to emerge. When I got involved with Node, it was 2015. I was told very emphatically by the core contributors that were there, Node is not a browser. It should never act like one, right? None of the APIs that existed in the browsers, none of those should ever exist in Node, right? The way that Node works, it had a whole different set of use cases that never would, that would never apply to the web browser, right? But in reality, we know that's not true. Both browsers and Node do streaming, right? They have to work with streaming data. You have to work with text encodings, right? UTF-8 content or other things like that. You have to do encryption, right? You're working with keys, working with hashes, working with encryption, decryption, stuff. There's a lot of use cases. There's a lot of overlap between these environments, right? So, the one thing that I push back on really early is okay, Node's not a browser. It will never act like a browser, but, this idea that they are completely separate environments doesn't make any sense. But for the longest time, there was still just Node and the browsers. Now, the browsers all got together and decided, okay, we're going to make these things kind of, work the same way and have a consistent experience. So with all the browsers, even though there were a couple of them, well, now there's only one, but even though there were a couple of different browser implementations, that you could still lump them together, saying the browser, right? And as long as there are just 2 variations of something, people can live with it, right? You only have 2 choices. Okay, there's one way of doing it in the browser. There's one way of doing it in Node. We can live with that, right? And then a couple of years ago, actually, I can't believe it's been 4 years already. Along comes Dino, right? And it's okay, well, here's a third way of doing things, right? Yes, Dino came out right from the very start and said we're going to implement all of these standard APIs, but they also have this Dino namespace, right? Where you can do file system operations and some, quite a few operating system specific operations using the Dino API. Well, now there's 3 things, right? 3 different ways of doing it. And then if you look at other environments like Cloudflare Workers, well, okay, here's an entirely different kind of thing. How is that going to work? Now, the decision was made early on with Workers, thankfully, that they were going to be compliant to the standards. Except when I got there, I've been there for about 9 months. Yes, they had implemented all of these specs in the browsers. Not a single implementation was conforming to any of the standards, right? So the APIs were there. None of them worked the way that they were supposed to. Right, and then we start looking at other environments. Fastly, right? It's great environments. Mostly standards compliant. They're getting there. And you have other environments. Bloomberg did a full JavaScript-based environments. And you pull in stuff with TypeScript, and you start looking at it, there's a lot more than just the two things, right? It's not just Node and browsers. What you realize very quickly is there's this massive ecosystem that all has to work together. And I don't think any one of us only work on one part of those things, right? We're either on teams that are doing the full stack. We're using multiple tools. We're tying these things together. So why the hell are we doing the same thing different ways in different platforms, right? Why should there be one way of doing file system operations in Node, a different way of doing it in Dino, a different way of doing it in the other environments? Why should Node have a specific way of doing crypto that only works in Node, right? These things don't make sense, and all they do is add friction to the ecosystem and make it harder for us to do the job we need to do. Now, for the longest time, Node was the platform I worked on. So it's like, okay, I'm going to do Node stuff, right? Then I went over to Workers, and I realized how hard this actually gets for developers. One of the questions I've constantly had over the past few months was some random module out on NPM, right? How does it work in Workers? Unfortunately, it doesn't, right? Because it's going off and using some set of Node APIs that only work in Node. Now, Dino's solution to this has been, we're just going to emulate Node, right? So they have this whole part of their standard lib, this Node subsection of it, where they're actually going off and polyfilling all of the Node core APIs. Well, it turns out in Workers, we're going to end up having to do the same thing. And it really sucks, right? Because it just adds maintenance burden to the runtimes and makes it really hard. So is there a better way of doing this, right? And the answer is yes, and it's always been there from the beginning, right? And it's focusing on web platform standards, right? And starting to leverage that set of, that ecosystem that already exists in browsers, right? So it was about, well, I just say, kind of winding it back a little bit, I tried an experiment, and this was, about 4 or 5 years ago with Node. We had a buggy URL parser. So if you've used the url.parse API in Node, it works, right? It's fast, but it has a number of bugs in there where it mishandles things like the username and password in certain cases. There's a lot of little edge cases. And we tried to fix those and ended up killing the performance of it. It turns out that bit of code is so performance optimized that if you look at it wrong, it's like, it slows down by 20%. It's like extremely clever and non-maintainable code, right? But it's there. We're not going to remove it. But I decided at the time that I was going to try an experiment. For a couple of years at that point, I've been hearing, okay, Node's not the browser. It shouldn't act like one. But I said, okay, well, browsers have this URL class. It works. It's, standard. Everyone seems to, agree that it works. So why don't I just implement that and see what happens in Node? And it just went in. Like, folks were like, okay. We had a few complaints about it. Some folks were like, well, URL parse is good enough and stuff like that. But it ended up just working. And I was actually surprised at how well it worked. And they were like, okay, let's try a few more things. And it took us a few years. But, we have abort controller in there now. We have abort signal. Event target, right, is in there. Fetch just landed, here recently. It's fantastic, right? So we're really starting to grow these things out. Web streams, right? Readable streams, it's there. I caution you, it's slow. It's very slow in Node compared to Node streams, but it's there, right? And I think for me, just the fact that it is available there, and then you can write code that works a consistent way, right, in Dino, in Node, in Workers, and in the browser, and have this code that that consumes streams and it just works, right? Is critical. So it's been a long process. There's been a lot of folks that have been involved in kind of making that happen. It has taken a number of years, but we now can say definitively that there is a significant API surface that is common and shared among all of these runtimes. Now, if you look at browsers, if you go to MDN, there's a page in there, this web APIs, right? It's all the APIs that exist in browsers, and there is a ton of them in there, right? It's like a never-ending list, and it's growing all the time. get the question all the time, folks who are like trying to make the slippery slope argument. If I add URL, that means I'm going to have to add GPU render, something, right? And it's like, well, no, okay. There's never going to be a time when everything on that list is going to be available in all these runtimes. What we will have, though, is what that common subset is, right? We will identify where the overlap does exist. And I think, we've actually identified pretty well today what that subset is, and we're moving forward from there. So that brings up the next step. Part of this was just getting acceptance within the projects that, okay, it's okay for Node to act like a browser a little bit, right? And it really, to me, just give credit where credit was due, it was Dino that pushed us over that edge, right? Because Dino took all of the arguments off the table. Like, if we can do it, you have no excuse not to. Right, so I have to say, Dino is an amazing project, fantastic work that's happening there. And so really thank that team for giving Node the extra push that we've needed. But just having the implementations available is not enough, right? We also have to make sure they work correctly together, right? A couple cases in point. The workers stream implementation, like I said, it didn't work the way it was supposed to. It wasn't just that it didn't work, it wasn't slightly off, it was entirely off. All the defaults were different than what the spec called for, and just all the behaviors were there. So it required basically rewriting the whole thing. All right, so now there's actually 2 implementations of streams and workers because I've rewritten that. But there's still that additional step of how do we make sure that it's there. And unfortunately, going back to it, it's already a solved problem. We have the web platform tests. These are all the tests that exist in the browsers use to verify that yes, they are actually compliant to what they're doing. So what we're doing, within Node, what we have been, for a while, and what Dino does, and what we're doing with workers is now we're all saying web platform tests are the standard that we will use to verify that we're all actually working together on these things and moving these things forward. So that was kind of the second pillar of it, just deciding, yes, we're just going to do that, and whatever they say is the right way, that's going to be the right way. The third thing, though, was, and this is actually a big one, if you look at the history of how some of these specifications were put together, so web streams is just continue with that example. Web streams work really well in the browser. They were designed with all the browser use cases in mind. Unfortunately, they don't work so well in environments like Node. And they'll work, right? It functions, but it's a massive performance loss compared to Node streams. And it has to do with the way that Node streams is actually based on a purely synchronous API, right? Which is Node's event emitter. All right, all of that, you can use Node streams asynchronously, scheduling calls based on the file system. There's all kinds of techniques, but the API itself is fundamentally synchronous, right? Whereas with web streams, they're promise-based, right? After every operation, you have a continuation. You're allocating a bunch of promises. There's a ton of additional overhead that actually carries into that implementation. And there's also small other little details, like with a web stream, if you tee it, right, and you're sending the data down 2 different branches, 2 different readable streams, you're actually supposed to do structured clone in between there so that each branch gets their own copy of the data. Whereas with Node, you're just passing this reference to the same objects through, right? The buffering is different in web streams. There's a lot of little details that just add to the cost. But the other cost to it was, little things like in web streams, they define that a readable stream can be transferred. So if you use post message, like in create a worker, or create a worker and then post or send that stream over, that stream has to be able to be marked as transferable, all right? Now that's easy to do in C++ if you're just using the V8 APIs directly, right? But in Node, the APIs are implemented entirely in JavaScript, right? And it's very difficult to get V8 to actually, treat that object, that JavaScript object, as transferable, right, without a fairly significant performance loss. We actually have to, there's a way that we have to tag that class that adds a significant amount of overhead. So it means the implementation is a lot slower. Now, I'm going into a lot of detail here just to, to say the point that, there's a lot of details that are in the spec that did not take nodes' use cases and requirements into consideration, right? In fact, if you look at the WhatWG the working group, if you look at their charter, in their charter, they specifically say, we only care about the web browsers, right? The web browser use cases are the only ones that we will consider, right? What gets standardized in a WhatWG spec is whatever the web browsers are interested in implementing, right? So if, and there's been times where Node has come up and said, well, hey, we like the API, but could you do it like this for us? And the answer has been, no, they're not going to do it because the browsers don't need it like that. The browsers don't care, right? And part of the part of the issues and stuff that have existed have been just Node has just refused to show up at the table, right? They've refused to have the conversation, and they've kind of thumbed their nose at it and said, okay, if you're not going to listen to us, we're going to keep going and playing on our own. Fortunately, we've gotten past that. We've started the conversations, but WhatWG and WICG, which is the web incubator community group within W3C, they are still only chartered to focus on the web browsers, right? That's what they have to do. So as we were, as I was starting to have a number of conversations with the folks on these various different runtimes and looking at this ourselves. In fact, it was probably back in January, we had a couple of Cloudflare customers come to us and say, hey, we need more standards focus, from you and stuff like that. We just, we discovered very early that there was a gap in the ecosystem right now. And that gap is really bringing these runtimes together to really advocate for these additional set of use cases that have been largely ignored by the standards up to this point in time. So we created what was called the Web Interoperable Runtimes Community Group, right, or WinterCG for short. WinterCG is it's a community group under the W3C. So we're operating under the intellectual property guidelines of the W3C. Anybody can contribute though. Like any individual can jump in. You can represent either yourself or your company. If you represent a company, then that company needs to be a member of the W3C, and your representative has to nominate you and that kind of thing. There's a small process to it, but any individual can also jump into it. We have a GitHub repo that is just open, public, right? Anybody can jump in and talk about, join the conversations where you have a matrix channel and that you can jump into. Completely open process. The idea is we're not going to gatekeep anything, right? If you have an interest in what we're focusing on, then then jump into the conversation. But what are we going to be doing, right? What is the actual work of this group? One of the early fears, right from the start, folks were like, please don't create another standards group. Nobody wants yet another place to publish standards. So we're not going to do that. All right. We might have, a blog post or a note or something like that every now and then that we put together. But the idea is this is not a new place to create standards, right? What we will be doing is working with the WhatWG and WICG and W3C to push proposals to them, right? So, case in point, just recently, within the past couple of weeks, there was a new API added to Fetch, which is response.json, right? So it's, await JSON was already there, right? But there's a new static method there. If you just had, response with a capital R, .json, it will create a response object for JSON data. It makes it, eliminates quite a bit of boilerplate for actually returning JSON, using that response object. That proposal originated, Luca Casanata from Dino originated that and got it pushed through. The browsers weren't interested, right? And they don't really need it, right? But it's something that's super useful for the rest of us, right? And it makes things a lot easier. But within, we talk about it in this group, we get advocacy, like, it's kind of like, okay, within this group, this WinterCG, we actually now have a venue where we can go to all these runtimes and say, okay, are you interested in this? And can we collectively go to WG and say, this is something that is super useful to us, and it's not just Node asking, it's Node and Dino and workers, and it's a much broader slice of the ecosystem going in and saying, this is something that we really want you not to ignore, right, and push forward. So those kind of proposals, those kind of API changes where we are feeding into those existing venues is the thing that we really want to be focusing on. Another example, WebCrypto. Folks familiar with WebCrypto at all? One of its limitations, I mean, it's an okay API. I don't think anybody's happy with the API, but it's okay. One of its key limitations is it doesn't do streaming data, right? When you want to encrypt something, it's like you're encrypting a block of data, right? You can't stream it in. Same thing if you're hashing everything else. Well, it'd be really nice if that API actually had streaming. So we are actually working on a proposal to make to the W3C for a streaming WebCrypto API. So you'll be able to do encryption, decryption, hashing, and signature and signature verification using web streams compatible APIs, right? So the crypto stream, for instance, is going to be a transform stream in the stream sense. You write plain text data to the writable side, and you're going to get the encrypted data out on the readable side, right? So fully compliant with the standards, but we do not want to write that as a separate spec. We don't want to have a separate standard. So what we're doing is working with the W3C. They are actually in the process of launching a new working group to kind of revisit WebCrypto, and not just on the API side, but also on new algorithms, some of them updating the algorithm set that's there. So the goal of the job of WinterCG, that work stream, is going to be prepare a document that describes the changes we want to see, these additions we want to see, work with the W3C to actually get those integrated into the spec. So we're not going to do something off on our own. We're actually going to work with the browsers, with the and with the W3C on actually moving that forward. That's one of the work streams. Now going back to this idea of this standard lib, right? Fortunately, the standard lib for JavaScript already exists, right? It's already there. It's what browsers have already implemented. So what we did is we went and did a survey of all of the web platform APIs that existed in Node and Dino and workers, just so we could limit the set. We limited it to those. And we said if an API exists in just 2 of those, it's going to get added to the list. And this list, what we're calling it is the common minimum API service, right? And we're actually going to write that up, and we have a note, a draft note that we're writing up, and it's not going to end up as a spec. That's kind of the format that it's written in now because it's standard W3C format. But our intent is not to publish that as a specification, per se, as much as just documentation. Like these, if you're using these runtimes, if you're using anything any runtime that purports to be web interoperable, should have this set of APIs. And not only that, they should all work in a consistent way, right? And they should all be compliant to web platform tests. Now, where there are variances, and I'll talk about that in a second, where there are variances which are inevitable and necessary, instead of just letting users discover those, accidentally, oh crap, this doesn't work here, right? It's that, we're going to be saying, those things need to be documented. They have to be clearly articulated, like kind of what the variance is, why it exists, right? And is there a plan to move away from it, right? Example there, nodes set timer and set interval. It's there, it exists, but instead of returning a number, which is what happens in browsers and every other environment, it returns an object, right? It's a variance from the spec, right? Will it ever be changed? No. Right? So, kind of the standard that we're going to say is, okay, well, at least that needs to be acknowledged, right? There should be documentation that clearly states, here's where we're different, right, on this particular API, and, here's why, right? And here, if you do need to get it close, close to what the actual standard behavior is, here are some mitigation steps that you can follow. So, there's going to be some of those things that there's going to be continued work going in on that, but that's kind of where we're heading. Okay, so that standard API, like I said, it's kind of a, kind of thing like, is this brand new? Is it something that we're going to be creating? No, it's what you're already using, right? And we're just going to make sure that it's available in these environments. Okay, so that's WinterCG. The whole purpose of this was to introduce what we're doing, like what we're trying to accomplish. And highlight what we're not doing, right? A lot of folks have been like, right when I announced this, they're all like, oh, great, let's create this brand new standard for, for whatever. And it's been about a half dozen different things where people have suggested it. And immediately it's been, okay, no, we're not doing that. But if we have a use case for something that is needed, right? We can talk about things, missing standards, but the right place to have those conversations, go to the W3C, go to WG, right? And have the conversations there where we can actually focus on moving those standards forward. Okay, and that's it. So, thank you. If folks are interested in talking about, getting involved or have more questions on it, feel free. I'm going to be here, be here all day today and tomorrow. Actually, the rest of the week for the Collaborator Summit. So feel free to come up and chat. Okay.